So what can we use all of this for? Well, one of the things that it's used for is to do radiometric dating. You probably heard of carbon dating. That's a really easy way to determine the age of something that's reasonably recently created. The idea behind the radiocarbon dating is that we can measure how much carbon-14 is remaining, because carbon-14 is radioactive, it's unstable, and it decays into garden variety nitrogen. So we can find out how much of this is in a sample by seeing how radioactive the sample actually is. And you don't think of all the living creatures on this planet being radioactive, but they all are. While you are alive, or while a plant is alive, it is taking in carbon. And it's taking in carbon that has been turned into this unstable isotope in the atmosphere because of the radiation of the sun. Once it dies, it is no longer taking in new amounts of this isotope, and this will start decreasing. And a lot of times, if you are trying to work with a problem like this, they'll be simply asked for the age of the sample. If that's what you're asked for, all you're trying to do is to figure out this formula, how much there is now to how much there would be if done today. Take a logarithm. And then this, what's the half-life? Well, the half-life of this particular carbon breakdown. Given that, we are going to do a problem. This is very common because carbon dating is very good for rather recent things, recent being a flexible term, but archaeologists are always trying to figure out the age of various things that they have found. And if they found something that's made out of a once living organism, like something made out of wood, then they will start wondering about the age of things. In this problem, they're talking about a tunnel that was discovered in Jerusalem, all right? This was said by historical record to be built at a certain time, about 700 BC, okay? But somebody found an inscription on the wood that said that the tunnel was built somewhere in the range of 200 to 100 BC. And then someone said, well, we better just grab a little bit of this wood and do some carbon dating on it. When they did that, they found the date was closer to the 700 BC. Apparently what happened is maybe somebody did some repairs and then they put an inscription on it from when the repairs had been done. But here we have a question, finally, after all of this background information. Why would we want to do this? Because somebody in the archaeology department wants to know the answer. So what's the ratio of carbon-14 in a wooden object that was made in 100 BC to one made from the same kind of wood in 700 BC? I know that how much there is at a particular time depends on how much there originally was, and then it undergoes this exponential decay for that period of time compared to, T1 compared to time 0. So I have a situation where this is the type of formula I want to use, and I'll identify this first one, T1, as being 100 BC. You might as well say that's negative 100 compared to our 2020. I can also say that another one at a different time follows the same format, and the only thing different is that I'm going to put a T2 up here in this exponent. And I'm going to say that T2 was 700 BC. Now, it is important to note that the way I've written these, I am looking at it from the point of view of a time before this had happened. Our N0 is sometime before this time. Otherwise, how would I do this? But what I could do is say, hey, you know what? If this is 100 BC and that's 700 BC, even longer ago, right? I could just say they are asking for a ratio of the one in 100 BC to the one in 700 BC. So I'm just going to set these up as N1, which is the shorthand for N at T1, over N2, same shorthand. When I do that, I would be putting these two formulas up here like this. I'd be able to cancel out those and combine it, since they're both E's, to be minus K T1 minus T2. What's the difference between T1 and T2? We're going to say that difference is 600 years. If I look at it like this, I'm sitting there going, wouldn't it be a negative 600 years? And so this is kind of confusing. But remember, these were written from the point of view of before, and we are looking at it from the point of view of after it occurred. So I'm thinking that this is the right way to approach it. The other thing I can figure out is what's K, because they, at some point, should give me the half-life. They didn't in this problem, but I can go look up the half-life for carbon dating, and I'll find out that that half-life is 5,730 years. Well, that's good because these are in years. So I'm glad everything is going to agree. That will be 1.21 times 10 to the negative fourth inverse years. So what then is my E that I am calculating? It's minus the 1.21 times 10 to the negative fourth. And then it's going to be the 600 years. So you see, the years are going to cancel out. I'll have a pure number, which is good because I need a pure number to be an exponent. This will end up being E to the negative 0.0726. And when you use your calculator, it will say that that is 0.92997, which is way too many sig figs. So that's approximately 0.93. And what is this 0.93? It's the ratio between N1 and N2 from the point of view of a time before that. We are looking at it as a time after that. So what I should be saying is that N1, because it is more recent, will have more of the carbon-14 than the older sample N2. How much more? Well, I can look at this and say, oh, must be about 7% difference, because one of them is 0.93 of the other, right? So 7% more in the more recent sample. Another way we could approach this problem is to simply say that NT1, I started out with all of my substance, and I am decaying for how long? Well, they said they did this in the year 2003, so we'll just call that the year 2000. And they said it was from 100 BC. So that's a grand total of 2,100 years. The other one, for N at time 2, it started out with the same amount because it's out of the same type of wood, but because it was created more years ago, instead the number of years that have passed are the 2,000 years plus the 700 from BC. So that's 2,700. Now, if I want to compare these two, I can see that N1 compared to N2 would still be the NO, and here's E, and I'll change it to 2,100K. And N2 would be NO, and E to the minus 2,700K. The NOs are going to cancel, and you're going to get E to the minus 2,100K minus a negative 2,700K. And you're going to get E to the positive 600 times K, which is what we had gotten before. So E to that number is also going to be N1 over N2. So N1 will be bigger than, you're going to get a slightly different number here, and that still looks like about 7% more than N2.